Exercise 11H, miscellaneous. Let's start off with the first question. Now, this is also a typical sort of a type of question you'd get in your exam. The only difference is that part there is doable in the sense that it links easily. The ones that I'm talking about, integration by recognition, it's where you can't find that one and you have to manipulate it so that you can find that. And I'll show you some of the questions, only a few of them in your textbook that gives you an idea what you need to do. But they always do it, and how you know when to use it is they will always say differentiate first and then they tell you to integrate, or they say hence. That's normally the hint. So if you look in your past exams, if you see, normally it's question 7 or 8 in your exam 1, then normally will say, this is your equation, it's normally log or sine or cosine function. They'll say differentiate it, are they using product rule or quotient rule? And then the next part they'll say hence. Okay, and that part there most students will lose marks in. This, most students will do okay. And it's the next mark that students find difficult instead of doing, they don't know how to do it. That's a very simple idea, okay? But for this one, it's pretty straightforward. First step, you're just now revisiting quotient rule or product rule. You got a function, you got f of x equals to log e of x squared plus 1, and they're asking you to find the derivative. Okay, so show that the derivative equals this. Normally they say differentiate. Okay, so in your exams they'll say differentiate. In this case, they're saying find f dash or show that f dash equals to 2x over x squared plus 1. So let's recap. What do you do? How do you differentiate log e? So you've got f of x equals to log base e of x squared plus 1. How do I differentiate this again? What's the technique called? Can I please have Stephen Zhao? What technique are we using? How do we differentiate this? You forgot the name. Okay, that's all right. What do you do though?
I'll differentiate the inside of the log e first, then differentiate that.
Fantastic. The name starts with C. Anyone remember? Chain rule. Fantastic. Differentiate the inside and then differentiate the outside. You're absolutely correct. So differentiating the inside, derivative of x squared plus 1 is 2x multiplied to the derivative of the outside. Derivative of log, what is that, Pius? What's the derivative of a log again? Good. This would be 1 on x squared plus 1. So normally derivative of log is 1 on x. But in our case, we've got log of x squared plus 1, so it's 1 over x squared plus 1. So if you multiply those two together using chain rule, you get 2x over x squared plus 1, which is true. Okay? So chain rule. It's called the chain rule. Next one. Now it says, hence evaluate the antiderivative of x over x squared plus 1. Okay, so what we want to find out is this. Integration of x over x squared plus 1 dx. This is a definite integral, so recapping again how to find a definite integral. First thing is you need to be able to antidiff that. Once you can antidiff that, then you can sub in the top end, so upper bound and the lower bound, and find the difference between the two. Yeah? The problem is we don't know how to antidiff that. We know how to antidiff it was 1 over x plus 1 all to the power of 2 or something like that. Yes, we do. But we don't know how to antidiff that. So that's why there's always the first part. They'll tell you find the derivative, and then now use your derivative answer to find what you want. So right here, what you can see is these two are very similar. What's the difference between the two? This has a factor of 2. Multiply. So another way of thinking about this is 2 times x over x squared plus 1. Now why do I want it like this? Because you know, if you found the antiderivative of this, what should that give you? If you found the antiderivative of this, what should that give you? Let's go, yes, Steven? Yeah, the log, because that's what you did. You said this is f of x, derivative gives you this, then antiderivative gives you f of x. So we know the antiderivative of this should be log e of x squared plus 1. But I can rewrite that now. I know that this is the same thing as saying 2 antiderivative of x over x squared plus 1. So now that looks kind of like this. Okay, so what's the difference between the two? The only way to not have the two if you think about it, the only way not to have the 2 is if we now say, if I multiply, if this is equal to log e of x squared plus 1, if I know that's the antiderivative, the only way to remove that 2 is if I multiply this by half. See what I'm doing there? See what I'm doing there? So if I said half of log e of x squared plus 1, it should be the same thing as saying half of 2 times x over x squared plus 1. What's the benefit? 2's cancel out, and suddenly antiderivative of x over x squared plus 1 is equal to half of log e x squared plus 1. That's what this is. Okay, so now I know. So what I've done is I've just manipulated it, because I know if I don't have that factor of 2, then I have to divide it by 2 to remove that, then I divide this by 2. If I divide this by 2, now I know what that equals to. See, now I know the antiderivative of x over x squared plus 1 should be half log e of x squared plus 1. See what I'm doing there? And then now you can use definite integrals. So you can say this is your lower bound 0, upper bound 2. How do you evaluate this again? It's called fundamental theorem of calculus. I taught you the technique. I haven't told you the reason. I taught you the technique. What's the technique again? What do you do again, Sebi? What do you do from here? So I've anti-derived that. I know that antiderivative of x of x squared plus 1 is equal to this. Yeah, you sub in the 2 and 0, so your upper bound. So if you remember fundamental theorem of calculus, you sub in 2 into your function, find the difference of f of 2 and f of 0. If I sub 2 into the equation, I have half times log e of 2 squared plus 1. Subtract half times log e of 0 squared plus 1. Whoops. Okay, so now we're just solving it. This now becomes half log e of 5, take away half log e of 1. Anyone remember what's log e of 1? What's log e of 1? 0. Another way of thinking about it is e to the power of something equals 1. E to the power of 0 equals 1. So I know this is equal to 0. And so you're left with that. So my answer is half log e of 5. Or you can say log e to the power of root 5. I mean, sorry, log e of root 5. Log e of root 5. Log e of root 5. Okay? Any questions there? Now, the thing that makes this tricky was this is what you want to do. This is what you want to integrate. The only way to get there is you manipulate your derivative to get what you want. Now, this manipulation is easy because that was a factor of 2. So what you did was you divided both sides by 2. What you got to do in the ones that are in the exams is you have to move a whole bunch of integration to the right-hand side to get what you want. Okay? Now, I'll show you what I mean. Let's move. Is it that one? Yeah. I think it's this one. I can't remember. I just had a brief glance at it, and I think this is one in which you need to manipulate. No, maybe not that one, actually. Let me look. No, it's one of it. Yeah. One of it is really useful for you guys to learn from. Maybe it's 3. Wait, it's 6. Actually, on a second, listening. Let's try to do, I think 4a should be a good example. So I'm going to copy that. X, actually I should do this. Area 12. Let's do question 4A. 4A. I'll try to show you what I mean by manipulating your equation. Okay, so let's have a look at 4A.
You've been holding on to that one though.
F of x is equal to x log e of 2x. It's typical in your exam, the first part of the exam question would say differentiate, or in this case they say find f dash of x. So A, most people get the mark from. It'll be like 1 or 2 marks for that one. Okay, so you get find f dash, which really just means differentiate that. Okay, so it's either a quotient rule or product rule or chain rule, whatever it is. Most likely it's a product rule most of the time. You get a product rule. Okay, so in this case we know it's a product rule because it's x multiplied to, so it's a linear function multiplied to a log function. So that's a product rule there. Okay, so what is our product rule again? You've got f dash of x is equal to, it helps, Victoria Beauty, VU dash, good, so VU dash, not minus, plus. Minus is for quotient rule, plus is for the product rule. Okay, so product rule VU dash, Victoria University first, and then UV dash. Okay, that's your rule. Now let's differentiate this. This is differentiating first, and I'm going to show you how you then do the second part. It says find the integration of log e of 2x. That's what you want. So integration of log e of 2x. This is called integration by manipulation. So let's try this. Let's find the derivative first. We found the derivative. Okay, you'd say let's call this v. Let's call this, u. Let's call this v. Okay. If I have v which would be log e of 2x multiplied to u dash. U dash is 1. Okay, because u is x, derivative of x is 1, plus uv dash. So u, which is x, v dash, so x multiplied to v dash, which is log e of 2x, and derivative of log e of 2x, which is 1 and x, good. This simplifies down to log e of 2x plus 1. Great. Okay, so we've now done product rule. That's your first 1 or 2 marks. Product rule, 2 marks. In the next question, they will always say, and normally they'll give you an interval. In this case, they normally give you like 0 to 10 or something like that. From here, the reason why it gets hard is because what you're looking for is part of where it is here. And we don't know how to find the antiderivative of log u of 2x unless we're doing special of some sort. But we don't know how to do this. Most of the questions that you get in the exams are going to be some sort of circular function. So it could be like tan of x on 3 or something like that. And your goal is to manipulate the derivative so that you get what you want. So in our case, this is what we want. We want to find the antiderivative of log e 2x. We don't want to find the antiderivative of log e 2x plus 1. So there's that extra plus 1. So this is how we manipulate it. What we do know is if this is f of x, then the antiderivative of this, which is the derivative, this is f dash x. Antiderivative of f dash should give you f of x. Do we agree with that? Yeah, so what I'm trying to say is I'm going to say antiderivative of f dash of x dx should give you f of x. Right? So I know the antiderivative of log e 2x plus 1 should equal to up here, which is x multiplied to log e of 2x. That's what we know. And that's the first step we should be doing in the next part. So if this happens to come up in the exam, it comes up like once every 2 years or so. So I don't know if it's going to come up or not. But it's a typical one. And you'll know when it comes when they say differentiate and hence. Okay, so differentiate now hence. This part here, what I want is I want this. That's what I want. Okay? I want to find the antiderivative log e of 2x. The problem here is I don't have that. So right now I've got antiderivative log e of 2x plus 1. So what you can do is why we call it antiderivative by recognition or antiderivative by manipulation, is you're going to manipulate this. So I can split up this integral into two parts. I can integrate it as log e of 2x dx, that's a plus there, plus antiderivative of 1 dx. So what I'm doing now is to split up the integration into two parts, and this now becomes x log e of x, because I know the antiderivative of f dash should be f of x. Anyone confused up to this step? Oh, 2x, thank you. Okay, so now why do I want it like this? Because this is what I want. This is what I want. Because that's what we've been looking for. We've been trying to get antiderivative log e 2x. I've separated the antiderivative of 1, so what I can do now is I can say, well, instead of plus 1 here, I can say minus integration 1 dx. If I minus one side, I can minus the right hand side, so minus integration 1. See what I'm doing now? So what I'm doing is I'm manipulating the equation. I'm manipulating this to get what I want. So now I can say, well, whatever this answer is, I'm minusing that answer. Cancel out. So what do I have left? I have now integration of log e of f of 2x. Integration of log e of 2x is equivalent to x log e of 2x minus integration of 1 dx. So we can do that. So this is something we can do. We know how to find the antiderivative of 1. And the antiderivative of 1, in this case here, x log e of 2x minus antiderivative of 1 is x. Let's see. Now this is easy because you haven't got the interval. Normally what they do is they say find 0 to 2, then you have to take that extra step. Now you have to sub in 0 to find out the w. That's why this is normally a 3-mark question. Together, it's a 4-mark question. Okay, so together you get 1 and 3, or 2 and 2. That's normally how it's split up. It's normally a question 7 or 8. I'll find 1, but this is what I want you to practice. So this exercise here, the part that's most useful is question 3 and 4. Gives you that idea of what you can expect on the exam. It does come up. Okay, so question 3 and 4. Everything else is just integration and sort of miscellaneous, but these are the ones that which I think you should know for your exams. Okay? So do practice, do 4A, B, and C, or 3A, B, and C. It gives you a nice feel of manipulating that equation to get what you want. In the meantime, I'm going to find the exam question so that you can see how they link. Okay, how they're both the same, except the exam one is a bit harder. Okay? So in the meantime, that's what I want to do. 3A, B, C, D, 4A, B, C. That's what we're working on. Okay, so revising our integration. Look at your notes again. So I'm going to go and find that exact question to show you what I mean. I think it's a 2014 one. Let me confirm. Let me find it.
You know what I'll do? I'll
Oh. This is an example, but you haven't learned probability yet, so it's still the same concept. Maybe I'll come back to that one. It's a 2016 one, that was last year's one. Let's find another one. Let's find it, 2010. Here we go. This is a good one. 2010. Question 9. This is what I mean. It's typical. In fact, it looks very similar to the one I just did for you as well. It's the same thing. They give you a graph. First part, always the biggest hint. They will tell you find the derivative first, and then they'll say use your answer, or hence. It's the same drill, same technique, same type of question. So you got, this is the graph. Find the derivative. So you got find the root x squared of log e of x, and then the second part here now says use your answer to part A. So whatever your answer was here, find the area of the shaded region, and all you need to find, if this is the graph, find the integration of x log e of x between 1 and 3, given that you knew this. Okay, and you're going to have to manipulate whatever you have in the derivative to get that area. So the area of this point, what I'm trying to say is, to find out the area, it's always antiderivative between 1 and 3. So what you're saying here is you're saying antiderivative, lower bound, upper bound. What you're trying to find is, this is your curve, x log e of x dx. The problem is we don't know how to do that. That's why part A, they tell you find the derivative, and then in your derivative, you're going to do what I did over there, manipulate the equation, so you get that only. So what you want is just x log e of x. You're going to manipulate it to get this. That's how you find the area. Okay, so part B is always the harder one. This one, product rule. Yeah. And I said it's about 2 marks. Oh, it's 1 mark. Okay, so it's 1 mark. Most likely the other one's 2 or 3. Where is it? I just lost it. Oh, lost it. It is. Oh. Why can't I get it? I'm all over the shop. It is 3 marks, yes, I'm right. It's in total 4 marks, 1 for derivative and 3 marks for the second one. So try this question. Have a go with this one. Same drill that I'm talking about. Same type. Okay, so have a go. So first find the derivative. This is what you want. Have a go with this one and I'll go through it with you. Okay, I want you to try this one. Find the derivative, manipulate the derivative to get what you want. So there was one in 2016 and there's also one in 2010. I haven't checked 2013 yet. It's nice to practice those. Yeah. We're just moving on to you miss out. I think you'll be missing out fundamental theorem calculus. It's just the meaning. So I will be tomorrow. James application or average doctor. It's like I don't even think I'll get there. I'll probably be on, I think by Wednesday. I'm still here, Jay. Thursday, it'll be Jay again. So maybe on by Jay. Average value. That's the theory, it ties everything together. Let's have a go with this one. Find the derivative, manipulate the derivative to find your answer. Then use fundamental theory calculus to find out the value. It's a 4-mark question. 4 out of 40. 10%. 10% of the exam. Something that's easy. Semi. I'm going to go cut these. Come back, we'll go through the answers.
It wasn't like full round, so just what it used to. George 2 years, not the only one.
Alright, let's go through the answers. Derivative. 1 mark. Let's go. First question.
Popular piano. Yeah.
You got your curve, you know your objective. First part's pretty easy. Find the derivative of x squared log e of x. It's 1 mark using product rule. How do you know? It's quadratic multiplied to a log function, so you're using product rule. So we're going to use product rule here. And remember, product rule was VU first, VU dash plus UV dash. That's what we want. You can call that U and you call that V. So if I said let x squared equal to U and let V equal to log e of x, then according to this rule here, then f dash of x, okay, the derivative of this, must equal to V, which is log e of x, multiplied to U dash, so derivative of x squared, which is 2x, plus U, which is x squared, so x squared multiplied to V dash, derivative log e of x, which is 1 on x. Okay, so exactly the same thing as what I've done in the purple over there, yeah? Now let's simplify that down. So this now becomes 2x log e of x. This is plus x squared times 1 on x. Cancels that, so you get plus x. Okay, so this is what we have. This is our derivative. So just remember, this is our derivative. What we want, okay, so always remember, what do we want? We wanted to find the area of the next question. They said, find the area of the shaded region. That's the first step. So the area of the shaded region, this function here is f of x is x log e of x. What we want is the area underneath it, so it has to be integration of 1 to 3 of x log e of x dx. The problem is we don't know how to do that. Okay, so that's what we want. This is what we want. The reason why they tell you to find the derivative is because within your derivative, you have that. That's why it's called integration by manipulation or integration by recognition, is you're trying to get this. So let's have a look at our derivative again. Let's look at the 2. This is my derivative. I want x times log e of x, and it's there. So I've got x times log e of x. The problem is, I've got the 2 and I've got the plus x. So, if I want the integration of x log e of x, I'm going to do that. I'm going to write it out. So right down here, let's write it out. Integration, so if I antiderive this whole entire thing, if I antiderive 2x log e of x plus x dx, what should that equal to? And that's where a lot of students found it difficult in this exam question, why a lot of students found it difficult. So they get up to this step and they're like, I don't know how to do it. So right here, this is why it's called recognition. So you have to recognize what you wanted. What's the antiderivative of 2x log e x plus x? It is? Good. See, a lot of students didn't know and they put that one there. Okay, or they just go back to the top and said, must be that. No, it isn't. See, what we did first was we derived this. So the derivative gives you this. The antiderivative gives you that. That's all it is. So if I just antiderive my derivative, I should be getting my function. And what was my function? That's what I derived. So derivative of this gave me this. That's why it's called f dash x. Then the antiderivative of my f dash should be that. Okay, it's just back and forth. It's like derive, antiderive. It's like saying derive x squared, which is 2x, and then antiderive 2x gives you x squared. That's the same thing. Okay, so antiderive this should give me that. So if I write out my equation, this is now equal to x squared log e of, was it x or 2x? X. Okay? That's nice. Why do we want that? Because remember, our goal was to get this. Our goal is to get just x and log e of x. So what you want to do is you want to manipulate this now. So how do you manipulate it? Break it apart. See, there's a plus sign. You can break these two apart. You can now write that as antiderive of x log e of x dx plus antiderive of x dx equals to x squared log e of x. See what I'm doing there? Okay, so I've just separated them. I've separated the antiderivative over here. I've separated the antiderivative over here. I've taken out the factor of 2, and this is what I want. So if this is what I want, move everything across. That's why it's called manipulation. So I'm going to move everything across. I'm going to say, all right, well, 2 antiderivative of log e, x log e of x dx should equal to x squared log e of x take away antiderivative of x dx. Okay, because all I'm doing is, if this is plus, I minus both sides. I've got the minus here. Finally, if I just want x log e of x, then I divide everything by half. So now my final answer is antiderive x log e of x dx equals 2, if you divide everything by half, it's half of x squared log e of x minus half antiderivative of x dx. And this is something I can do. So I can antiderive x. It's easy. Okay? And that one is sorted. Now what's the difference between what you need to do and what you've done? That was the hardest step. After that's just fundamental theorem of calculus, because now you know the antiderivative of x log e of x is this. Okay? So if I now put in the interval, so what was my interval before? It was 1 to 3. So all I'm doing now is I'm just saying, all right, I want you to find antiderivative of 1 to 3. Antiderive the x times log e of x, which is this. So I'm going to do this. Antiderive, that's my antiderivative, between 1 to 3. And exactly what you told me before, fundamental theorem of calculus. Sub 3 in and sub 1 in. Or it's easier if you just did 1 and 3 here, solve 1, 3 first. There'll be a number. And then you can sub 3 and 1 afterwards, and it makes it easier. But that's why it's a 3-mark question. You see, there's 2 parts to it that was really important It was the manipulation that a lot of students found difficult here because they couldn't see the link between the two. And your derived entire thing had to give you your original function. So that's your first mark. Your second mark is then getting to this point. Your third mark is getting the correct answer. Okay, so that's a lot of marks there, but it's a simple idea. And your textbook only has question 4, I think it is, or question 3 that deals with it. That's why it's only that's the only kind of practice you got. So try to understand what I'm trying to say there. They normally give you not something easy, especially when you get to this part. There's a lot of fractions, a lot of takeaway. People make mistakes in exam 1. Yeah. The other type is you have sine or cosine or tan. Those are the ones they normally put in. All right. But there you go. That's how you do this kind of question. That's a bit tedious to do, but it's worthwhile. 10%. 10% of exam 1. Simple if they come up. It's only been coming up sort of once every 2 years or 3 years. So you never know. Could be on it. On that, the bells are going to go in 3 or 4 minutes. Can you please practice just 11H, just those questions for me? That was good practice. Integration by manipulation. Be worthwhile knowing.